Real estate investment practice problem using Excel. Adjustable rate mortgage or ARM, no caps, part 3. Get ready, because we're raising the stakes with real estate. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we have 3 tabs on down below: example, practice, and blank. Let's take a look at them now, starting with the example tab, in essence being an answer key. We started off in prior presentations constructing an amortization table for a fixed rate loan, using it to compare and contrast to the adjustable rate or ARM loan. Then we put together our index and rates, thinking about what those rates would be, noting that when we're putting the loan together, then we don't know what the future rates will be. We just know they're going to be pegged to a index, and then we'll have some kind of margin that will be in place. So we can think about it from a projection standpoint, or we can think about it from a standpoint as time has passed and we know what the index is. I would prefer generally to think about it as some type of projection and planning, to think of what might happen in the future based on the index and our rate based on it. Then we calculated the payments, and then we looked at the ending balance, but we constructed the ending balance, and we can do so 2 ways. We did so first by actually constructing the amortization table as we go, as the rates change, and then picking up the ending balances from the amortization table, the 99,165 being the 99,165, year 2, 98,758 being the 98,758. Now we'll do that a separate way. Instead of picking up these balances from the table, if I double click on this item, we see a formula, which can be easier for us to do quick calculations with this table. However, I don't think it's quite as intuitive and doesn't provide that nice double check to see that the amortization table, or see how the amortization plays out. We'll do that this time, and then we'll take a look at the internal rate of return types of calculations that you can use for your decision-making purposes once you understand and can construct what the amortization table will look like, so you can do some comparing, some contrasting, running different scenarios, estimating what your risk might be. In the second tab, the practice tab, we have a pre-formatted worksheet, so you can populate that worksheet with some pre-formatted cells, doing less formatting as you construct it and practice. Third tab, the blank tab, that's where we will continue on here. So last time we did this table, which is our fixed rate table. Now we're over here. This is where we left off. We did our indexes, we figured out what our rates are, and then we used those rates and the payments and the ending balances. Well, we got the payments here in order to construct our amortization table. As we made the payments and adjusted the tables, we then looked at what the ending balance is after each time period. We filled that into our ending balance here. In other words, these cells are coming from the amortization table itself, right, like so. So there we have it. So we kind of constructed it as we go. Now we're going to go back and try to put a formula into these ending balances instead of pulling them from the amortization table, which can be a little bit quicker for us to kind of construct these, but again, a little bit less intuitive. We can double check these numbers then to the ending balances in the amortization table. So I'm going to delete this whole thing. That'll mess up the payments here as well, but the payments will populate again once we get the proper balances in place. Okay, so this is one way we can basically do this calculation for the loan, for the ending balance. So we've got the balance first starting here. We used that balance in order to calculate the payment, just as we would, in essence, if we had the same payment for a fixed rate. Then we need to know what the ending balance is after a year, so that we can use that to think about what the next payment will be, and so on and so forth. So we could do a formula to figure out that ending balance. So this is one way we could do it. So we're going to say that this equals, we'll say to the payment to the left, which we calculated, the 733.76 divided by, then we're going to embed the payment calculation. I'm going to do that with a negative PMT. There's our payment. We could double click on it. The rate then is going to be that 8%. We're going to divide that by 12. And then we're going to say comma. The number of periods, this is where it gets a little bit tricky. We're going to look at, we want 29 periods in essence. So I'm going to put brackets around it, and then we'll multiply it times 12. So we want the 30 over here. When I copy that down, I want it to copy down, and that's outside of our table. So I'm going to say F4 on the keyboard so that doesn't move when we copy it down. And then we're taking that minus 1 over here, which will give us 29 years, closing that up, and then multiplying it times 12 to get the monthly amount, and then comma, and then here's the other strange thing. The present value is not going to be the prior balance. We're just going to put 1 here because we're trying to back into the loan balance at that point in time after 1 year. So I'm going to say enter. So there we have it. Let's try it. Let's practice it a couple more times. Notice that this payment now populated automatically because we copied this cell down and it needs this cell in order to populate. So that you got this staggered kind of thing. You could still copy these formulas down, but because they're staggered, you know, they depend on each other before they'll be properly calculated. Now this 99,165 we can double check by saying it's right there, 99,165. Let's do it again. Let's do it a couple more times because it's a strange formula. We could say this is going to be equal to the prior cell. We're going to divide that by the rate. And then we're going to take that divided by, well, hold on a sec. We're going to divide that by the PMT, negative PMT, then the rate, which is going to be the starting point of our payment, 12, and then the 12% divided by 12, comma, the periods, brackets. Looking at the years, we're looking for 28 years now, so we're looking 30 minus, then the 2, so I can copy it down. That 30 would need to be absolute if I was to copy it down. F4, $ before the L and the 5, closing the brackets. That would be 28 years to times 12 to get the monthly amount, comma, and then instead of the prior balance, we're just going to put 1 here to get into the balance. So we're going to say it closes up the brackets. 98,758, is that correct? Let's check the end of the year too. 98,758 looks good. Let's try it again. This equals the prior cell divided by negative PMT, shift 9, rate is now that 15% divided by 12, comma, number of periods, brackets. It's going to be the 30 minus the 3 now, closing the brackets, times 12 to get the months, comma, then 1 for the present value instead of the loan balance, and enter. Closes up the brackets, 98,510 for the end of year 3. That looks right, 98,510 looks good. Let's do it 2 more times, equals the prior cell, and then we're going to say divided by, and then negative PMT, that's not a P, PMT, my fingers are on the wrong one. The rate 17 divided by 12, comma, number of periods is now going to be brackets 30, which I'm going to make absolute if I wanted to copy it down, then minus the 4, closing the brackets, multiplying times 12, then comma, and present value, not the prior balance, but 1. And I can close up the bracket so it doesn't give me a little thing, doesn't ding me. 98,310, let's check that at the end of year 4. 98,310, let's do it 1 more time, and then we'll copy it down. This is going to be equal to the prior cell divided by, we're going to say the negative PMT function, shift 9, rate 12% divided by 12 to get the monthly rate, comma, number of periods, brackets is going to be 30. I would select F4 on the keyboard in case I wanted to copy it down because that's outside of my table, comma, and not comma, minus the 5 brackets times 12, then comma, present value 1, closing up the brackets, shift 0. There's our 97,732. 97,732 is here. Our amortization table is now at 0 at the end, it should be. That's our double check that it looks like it's calculating properly. So it looks good. Now let's do it 1 more time. I'm going to delete these and just copy it down. When I delete them, note these payments will be removed, and it'll look kind of funny, right? But these payments will be calculated as we go. Double click in here. The formula was the payment amount divided by negative PMT. The rate is here. I want it to move down because it's inside my table, so that's fine. Divided by 12. L5, that's the one that's outside. 30. I don't want it to move down when I copy it down. That's why there's an absolute reference. Minus N3, that one we do want to move down as we go, times 12, comma 1. Looks good. Let's put our cursor back on it and do the fill handle, dragging it down. And we should once again get our calculations for those payments. So there we have it. So next time, we're going to take a look at the IRR calculations, which we can calculate basically approximating it here on a yearly basis. And then we'll think about basically looking at our table to approximate those calculations as well. We'll also think about implementing a pivot table.